today's webinar is going to be featuring Rick Bastian of Water Furnace. So we'll just do a little bit of brief housekeeping here, and we'll turn it over to Rick for about the rest of the hour. So if anybody's interested in finding any of these webinars, you can feel free to scan that little QR code right there. That'll bring you to our YouTube site, bring you to our channels. It'll have last year's AHR presentations and all of the series thus far, and then we'll continue to add to that channel as well. So we look forward to you joining, liking, subscribing, saving these videos for later. They're very useful, very helpful, so keep them in your arsenal. Just a quick thank you to our sponsors. I want to thank the Unico Systems, Climate Control Group, Water Furnace, Taco Comfort Solutions, Plastic Pipe Institute, Nexus Valves, Alberta Hydronic Flow Control, IGSHPA, Federated Insurance, Tungstell Corporation, Surge Digital Marketing, and Geothermal Rising. These are our partners here at the RPA, and we thank them very much for helping us get these things off the ground. We're really excited to get to these free webinars out there to the public. So thanks to these guys. Just talk a little bit about where we'll be over the next couple of months. We do have IAPMO conference coming up next week. Hopefully some of you will join us. The conference goes from the 22nd to the 26th at Planet Hollywood Resort and Casino in Las Vegas, Nevada. We will be holding our meetings, the RPA, and the Hydronics Industry Alliance meetings on that Wednesday. Feel free to join us virtually or in person. We will also be at the AHR Expo in February, so we're really looking forward to that. 10th through 12th, we'll have speaking and education sessions set up for the entire week. There'll be RPA members speaking on panels. We'll have the RPA out there with a booth on the exposition floor. And we're just really excited to get out there again and share with you guys what we've been working on and talk to you just a little bit more about what it is we're doing here with this group and this organization. So again, hopefully you'll join us at those meetings. Those are the two in-person meetings that we do twice per year, IAPMO conference and AHR, and all the rest remain virtual. So again, we hope you'll join us. If anybody's interested in speaking, I forgot to mention there's a QR code there off to the right-hand side. We are accepting abstracts and looking for more speakers for that education panel mentioned earlier. So please feel free to take a look at that. Just some quick general housekeeping. So by the nature of trade associations like the RPA and HIAC bring together competitors, which means we are subject to higher scrutiny for anti-competitive issues. Antitrust laws prohibit the agreement and coordinated efforts of unreasonably interfere with free and open competition. Penalties and violations can be severe. IAPMO and all of its subsidies adhere to the antitrust laws and expect all webinar participants to do the same. During this webinar and any interactions outside of it, discussions and agreements that could restrain competition are strictly prohibited. This includes exchange of information of individual pricing, rates, coverages, market practices, claim settlement practices, or any other competitive aspects of the individual company's operations. Each participant is obligated to speak up immediately, and discussion stays outside of these bounds. Your continued attendance and participation in this webinar signifies your acknowledgement and acceptance to the policy. This session will be recorded and available for a later time. All attendees' mics will remain muted for the duration of the session, and please utilize the chat for Q&A. And if time permits, we'll have our speaker notified at the end, and we'll go through those questions with y'all. So a little bit about today's session. So see my screen. Today's section we have with Rick Bastian, Cost Clarity in Construction, How Best Software Delivers Feasibility and Budget Insights. So just a little bit about Rick. So Rick has over 50 years of experience in the plumbing and mechanical industry. Rick currently is a commercial business development at Water Furnace International. A lifetime member of ASHRAE, chairman of the Hydronics Industry Alliance. Rick has held executive positions throughout his career and is a U.S. patent holder. And it has served in key organizations like IGSHPA and the Radiant Professionals Alliance. Rick brings a wealth of knowledge to the RPA and his various committees, where he plays a pivotal role in the development of the best software, the building efficiency system tool that he will demo today. Today, he'll walk us through how this game-changing tool is transforming early-stage construction planning by offering parallel cost clarity for both contractors and building owners. So we'd just like to welcome Rick. And Rick, I will turn my screen over to you. And if you could just share your screen, that would be great.
Okay, and I want to share my screen. I think we see things I don't want to see. What I want to do first, and I'm going to go through the slides, but there's one thing about doing a slide presentation about BEST that doesn't really come through. In other words, it takes longer to describe the slides than the program actually works, the speed that it works with. So I'm going to try to open Best on my screen and show you a little bit about Best before we start talking about the details. When you first open Best, you get this, what we call the building wizard screen. And it has multiple purposes, but our first reason for this screen is so that without doing anything, without changing anything that has to do with the Best software, what's preloaded here is Chicago, Illinois, a building of 4 stories. It's an office building. That's not as critical as what we want to show you, that if you just click go, you see what is available from Best output. And with today's meeting, what we're going to talk about, of course, is the cost side of it. So what you're seeing is the end without having to do anything to create the information. So this is annual energy usage of 4 typical systems that go in an office building. I'll explain how that was selected, life cycle cost, et cetera. And you look at this and you go, oh, look, it's a buildup. It's a buildup of costs. We'll talk about that later. When it comes to the details of how this all happened, across the top of this screen, you'll see a project screen, systems that are being evaluated, some overview, and energy costs, monthly energy costs, life cycle costs, DEER, all these things that we'll get into. But this is happening, and it's happening fast, and it's happening live, so that you see, here's the first system, here's the details, here's the second system, here's the details, the fourth system, et cetera. Overview, energy costs, et cetera. And all of these things happen really fast. And what I'll show you really quickly is that if I went and say, well, I want to change something, none of those systems are what is in my building. So I want to look at a different system. I want to look at a ground source system. And you say, okay, now when you go back to the screen that quick, we've just now added a different system to the other 4 that were already there. It happens that quickly. What's critical to me is that you realize that it's that fast, and one other thing, Best is downloaded, and it's part of the history of it and why it's confidential. But when I click X up here, when I get out of this screen, it's gone. Your information is not being put in the cloud or being monitored by what's going on with our group. And that was part of it. So let me get into some of the details now about how cost got started, how Best got started, and what its intent was. And now you understand really one of the really critical things about Best is that it is super fast. So really how Best got started was multiple of us that are members of HIAC used to attend a meeting called Mechanical Exchange. And what that was, or what that is now called Vertical Exchange, is manufacturers' senior management meets with contractors' senior management. The idea being, oh, you go to a convention and somebody has a booth. Well, this is one-on-one private meetings. And you talk about the industry and what's going to happen and what you're doing. And what we found was that a repeated, regardless of which manufacturer was talking to which contractors, it was, we need more informed customers. And back in 2012 was kind of when this thing all really came together. And it was all about, our customers don't speak HVAC because they really don't have to do it very often. In fact, one of the things we really think about, or we need to pat ourselves on the back about, is that HVAC lasts for a long time. And in today's world, it's not the most expensive thing that's going on inside a productive building, especially we focus on commercial buildings. In the early days of Best, it was application engineers talking to professional engineers and designers, and all those information that you see, all those questions about it depends, they were blank. And we found out that if we left it blank, it kind of got into that, well, how much does this cost and how are you going to do it? And you say, well, it depends. What we found dealing with contractors, with manufacturers and PEs is we ask these simple questions. What would you really like to see? Well, we have to talk about the whole building because it's not just the compressor. It's not just cooling efficiency. The next question was cost. Well, how do you get to cost? Well, it depends. Even those contractors that had their own software, they said it's too technical. It's not conversational. How do we get to someone that's only going to make this decision once in the life of a building, and then later maybe only pieces of the building, to get up to speed about why we're talking about what? And what was starting to happen back then was what I call the marketing of HVAC. But what really happened when we started explaining to these manufacturers what we were going to do with Best, how it was going to be free, how it was going to be confidential, and how it was going to focus on a way to have a meaningful conversation about the impact of HVAC decisions. And that's when we found out through our beta testing of Best and Release that we needed to create wizards and examples. And essentially what we ended up doing, creating thousands of case studies with hundreds of ways that you can change the input in those case studies to make it yours. Best puts you in a case study about everyday business. Nobody wants to read about everyday business except when you have a everyday business kind of building to build. So decades of application, Best allows you to take your data and put it in a case study. So let's go back to that first screen. Once you've seen what Best can do, now this opening screen becomes the beginning way to get in a case study that's similar to what you're trying to deal with. You'll notice on all the screens that the project name is blank because we don't care about the project name. The project name is for you. If you save your output, if you save the Best information on your computer, we're not saving it. It's not in the cloud. But the very first thing that happens with most case studies is that the reason you want to watch that case study or read about that case study also becomes the primary reason that it doesn't work for you. It's really nice that somebody figured out how to use the heat from making an ice rink in the penguin exhibit to putting heat in the reptile part of the zoo, but who cares? Now that's an extreme, but Best is loaded with typical case studies. The first thing you do is make it yours. You make it your area. Then you're part of the country. And why we do that is because we use bin weather data. We use existing data. We don't make up anything. The building size, that helps because we need to know what's going to be involved in moving comfort around the building. How big is the building? And it also is looking at core to perimeter, but it's not doing what other types of software spend a lot of time doing, and that's calculating loads. We're giving you default loads that are typical with the idea that, as you will see continuously, that you can change it. Right in front of you, every one of those blocks that has an outline around it, you can change it. You change the building size, you change the number of floors, you get to pick, and you can see that that slider on the building type is only part way. So there's more and more buildings that you can look at. Once you pick a size, pick a state, a city, a type of building, then you get into your first case study. And now at the bottom, you'll see what systems that, based on these questions, we asked the contractors, we asked PEs, say, what kind of buildings do you do? They gave us that answer. The next thing we asked is, well, what kind of systems are typical for that building in your area? And they would say, well, normally this or that. There's no way they're going to do what I just showed you a minute ago. I just showed you 5 different ways to do an office building. They're not going to suggest there's 5 different ways. That's not going to happen. And with what they have, it's just too expensive to do that. So having these case studies where we kind of can take the profile, the what you would call the block model of the building and the loads, and say, well, let's look at it like this. And if you look at it like this, then here's what the cost impact can be from kind of an average situation. Now we know nobody's average, so that's where Best gets the conversation started, and Best does build-ups. What these colors represent is where the energy consumption of the different systems is coming from. And don't go crazy trying to read this chart because all of them are the same. The bottom is moving BTUs around the building. Red, we didn't mean that to be, oh my gosh, look out, we're doing gas, we're burning gas. It meant red was heating. That's all it meant. And blue is compressors. And brown is compressor heating, because that's something that we're talking about now. So when you go to our website, you get the tutorials, you get the basic information, you download the software, you click go, you get this screen, and then you start to get into the details. There's those 9 reports, and they're all focused. And why we got support is they're focused on generally what it costs to do something, and in a format where you can look at multiple different ways of doing it. But be careful, this y-axis, those dollars change with whatever it is that you're looking at. The best part, and where the discussions come from, is, well, here, yellow, that's the first cost. And then does that system have a life? Do you have to replace it? And then does the system have maintenance cost associated with it? And then what's the energy consumption of those systems? You're getting in the position to have a discussion with these 9 reports. The box model that everything's going to be compared to, not necessarily systems. It could be 4 variations of the same system, because you can change the efficiency. You can change the components. You can look at it today. Is it going to have a gas boiler, or is it going to have an electric boiler, or is it going to have a heat pump? What is it going to be? Then the overview, the energy costs that break it down annually, monthly costs that break it down by cost and by consumption, and then life cycle. And then we've added another page that you can review. So what's on this project page? Blank. That's up to you. Where, how big, and one of the first key items that has to do with best and cost is the cost of utilities, because the cost of utilities varies. The cost of utilities varies within the utility, but most businesses don't get to pick who their utility company is. So how do we fill this out? You've heard of EIA.gov. We go there, we go by state, we download the information. You'll see here that electrical consumption is one number. There's not demand, because EIA site it does a combination. But there's fossil fuel, there's natural gas, there's propane. These, again, you notice they've got borders. That means you can change them. You can go to your utility and say, here's our building and here's what we worked out. Can you do something with that number? 2 weeks ago, I had a company that has waste fuel boiler. They put 0 in here. There was even a discussion about having it be positive number, a number that actually a negative number, if you want to look at it that way. Heat loss, heat gain, most like Energy Plus and all those software programs that you're running, they're trying to figure out this part. We're giving you a number per square foot number as a default, but you can change that. You can put in what you have. You can enter a total and we'll break it down a little bit, but this is to get you started. Probably the biggest comment I get from contractors that are using this with customers, they say our customer isn't letting us design a building that uses 26 BTUs per square foot. And I say, well, yeah, but if you want to compare it to an existing system, maybe 26 BTUs per square foot is good. Maybe it's actually worse. And when we got information from these contractors, what I call the original 50, like one contractor gave us 287 projects because they knew it was going to be confidential, and because the way we were going to present the information, it wasn't going to be that you could go up here and pick a city and it would say X contractor charges you this much for a system. Because even though we make fun of once you ask how, the next question is how much, that's a pretty sensitive discussion when it's so general and at such a high level. But this allows those high level discussions to take place. So you can get better budgets because together you've agreed this is what we have to do. This is what we have to, this is our model that every system is going to be compared to. And then we can get into how are we going to do it? We agree on how's the space going to be heated? Is it a central system? Is it a terminal system? How are you going to cool? How are you going to move BTUs around the building? What's going to happen with air? If I put in this system, what do I have to do with DOAS? What do I have to do in order to get the ventilation air in? And then we've added something recently, which is we seem to get a lot of questions about what can we do with HVAC and domestic hot water. So we have a completely separate cost and consumption chart for the hot water based on the same type of thing that we were doing with the buildings. You pick the building, you pick the building type, it brings up the ASHRAE guidelines for what this typical building would use. Ideally, then you would change that to what your building uses, or you go to your utility and find out what buildings that are close to you, how they do things. These charts, this shows you, this is blue, and blue is cooling compressor use. And you can see that in the summer, it's a lot. And then as you get into the winter, it's less. But what is this chart about? This chart isn't about cooling compressors. This chart is about what it costs to do the whole building, what it costs to do heating and cooling. And I caution you, what's key in looking at this energy chart monthly as it goes across the bottom is what is that peak number? In this case, it's 10,000. You might look at another one, and although the chart looks the same, that top number up there might only be 4,000. But it's a discussion point. It's, oh, red is here. That means we're using gas. So it's a matter of how are we going to do it? And then we'll get up here. This and this is to remind me, folks, this is supposed to be about cost and how we treat costs. So when we look at it, here's the key. Those contractors, what I call the original 50, what building types do you do? What systems do you put in them? And can you give us nominal per square foot cost to show the difference? The ranges all across the 50 contractors. One was the largest mechanical contractor in Mexico. We had one contractor from Toronto, one contractor from British Columbia, and 47 contractors scattered out across the United States. No Alaska or Hawaii. I tried to go to Hawaii to interview a contractor, but IAPMA wouldn't pay for it. So when you have a default number, as I showed you, this number has a block around it. So you're asking, this system is based on a chilled beam, hot water heat, chill water cooling with an air-cooled chiller, and it's a 4-pipe system. In the building size that you have, that average cost is $30.86 a square foot. If you already know you live in an area that has lower mechanical costs, we have radio buttons that allow you to take it down. We have a high button that allows you to take it up. But 90% of the time, the way it's used is that number's zeroed out, and your contractor or whoever's giving you the input on your design team, you put in 25, 26, 37. It doesn't care. I don't care, because best isn't about picking a system. Best is about giving you enough information and comparing what you input. I had a gas company executive say, well, does Best select anything besides the heat pumps? Picking on me, of course, because I'm a water furnace guy. I said, Best doesn't pick systems. You do. You decide what you want to compare. You describe the system, and you and your team, or you and your facilities manager, look at it and say, this is what we want to look at. And now what's that cost? That cost compared with what you picked for efficiency, et cetera, combined with what you're doing with energy costs, combined with how long you want the energy cycle to go. And we have a discussion about, should we change energy cost inflation, maybe one for gas and one for electric. I give you an example. I had an architect call me from Reno, and they were confused about the output. Well, their input on utility costs was 18 cents for electricity, $10 demand charge, and 54 cents for gas. Those numbers and the impact on the output in Best will only get farther and farther apart as over 20 years they grow by 5%. So this is get the design team on the same page, understand what it is that you're going to compare, and then try to put some cost on it. And literally, there's no other fast way to do it, because in the discussion where you're saying, I'm going to heat water this way, do you have multiple heat sources? Do you look at the building and go, wait a minute, the building is a multi-use building. It's a productive building, but part of the building is this and part of the building is that. So when you set up your project screen, instead you go only a part of the building, only the part of the building that's sort of the same, only the part of the building that you're considering to remodel, only the part of the building that you're unsure what you want to do with it and how you can describe it. So each system page, you go back to it. Do I have one? I'll give you an example. You have different ways you're going to cool. You have part of the load handled with air source chillers, and then maybe at demand you go to turbo core chillers. Or you have a part of the building that's handled by modular chillers. Or you have gas, and then you have electric backup, or you have gas backup, or you have geothermal. And part of the geothermal system covers heating, the entire heating load, but that only covers 2/3 of the cooling load. So you can mix and match a particular building. You can look at how you're going to move BTUs around the building, and then what you're going to do terminal. And remember, if you want to look at your hot water usage, how is it that we address the two common problems that we have in the United States? We have warming and we have carbon. What's warming? Our part of warming is heat rejected to the atmosphere. When they talk about heat island effect in a city, it's because as far as we're concerned, we're rejecting heat from cooling. We're taking the heat in the building, we're adding the heat of the compressor, and we're throwing it away in the air. And how efficiently it does that depends where that part that throws it away in the air is located. We're a hydronic industry alliance. We would like to see cooling put into water. Number one, the cooling efficiency is higher, but number two, you've captured that heat to do what? Offset where you're burning carbon to heat. Not just hot water, but any heating, and the availability of more and more what we'll talk about as thermal resources. So multi-sources, individuals get on a template like this that's really fast, that's not requiring somebody to run some great big energy analysis and go to Energy Plus, but that we will basically have a simple conversational format or template to put your building or your remodel project in thousands of case studies with hundreds of ways to change and make it work. And this kind of detail. This is showing you we're moving BTUs around the building. Purple and yellow are moving, whether you're moving heating or you're moving cooling. And as I discussed before, brown, heating compressor. Blue, cooling compressor. Red, fossil fuel. Aqua is for fossil fuel cooling. We don't see that very often. The nice thing about those charts is under them are consumption costs and consumption in kWh or in fossil fuels, whatever. So you see the buildup, you see the discussion of, well, what is happening? I switched from this one to that one. I use less energy, but did I add more here? And how is that happening? So when you get into a discussion about a building that's only changing a component, now you see a change that I went from a gas fired system to an all electric system. What happened to me? The other thing that we do in BEST is we've introduced the term BEER. And BEER is basically an annualized building energy efficiency rating. It's the whole thing. It's all the in and all the out associated with cooling. It's not just the compressor. It's the whole building. So if you have DOAS that has to overcool the air, or you have to add something that's part of the system, well, how much of, as you can see these charts, how much is compressor and how much is everything else? That's what it gets you to. Now, when we get off of this meeting, you're going to go, what did he say? Well, up here at the top, there's a help button. And that help button, when you open it, you go down to methodology. Because most of the manufacturers that are in this group, we also do a lot of military contracts. And if you're going to take software into a military RFQ, you have to be able to show them, well, how does this program work? Where's the hidden algorithms? There are no hidden algorithms. You go to the help chart, and the help chart tells you exactly what's going on every page in every report. And then when you look at it, if you're a professional engineer or have that association with ASHRAE, you'll basically look at it and go, oh, this is standard stuff. This is nothing magic. This is how you handle equivalent load. How do you handle part load? What do you do with bin weather data? All of that stuff is right there, right in front of you, but it's a comprehensive look based on what is already being done. And that's the really fun part. So whether it's a simple system, whether it's a hybrid system like we've discussed, that you've got multiple ways that you're going to heat and cool, whether it's part of a building, that's what happens when you get into advanced systems. You can start working with all kinds of variations and not incur a bunch of costs, but what you're doing is justifying looking at, and as I showed you in the beginning, 5 different ways to do a 40,000 square foot office building. If you walk into an engineering firm or a contracting firm right now and say, hey, I'm going to do a little 40,000 square foot office building here in Oklahoma City, and I would like to look at the basic costs and system variations for 5 different ways to do that building. And they would go, how much money do you have and how much time do you have? Instead, armed with BEST, you walk in and you start a discussion and say, look, here's how it works. Here's some sample systems. Here's 30 other choices about what we could do. We're going to get on the same page. We're going to talk about different kinds of systems. Here's what we're looking at. Here's what we think can be done. Here's why we're thinking about it for your building, because we know one thing. Your building has to be a productive building. Commercial buildings aren't houses. It's not okay that you just want to live there. They have to be a part of being contributing to the bottom line. They have to be part of the success of what your business is about. They may even be the business itself. Is it the building like a hotel? You don't expect to go to a hotel and be told how long you can take a shower, et cetera, like what VRBO is running right now in their commercials. And yet, in the 70s, early 80s, I experienced going to hotels that said, really don't do those kinds of things. Things are changing. The world is changing. Demand has become a bigger and bigger deal because you can't do net zero. You can't talk about decarb. You can't talk about what your bill might be when all you look at is part load and averages and annual. You have to get into the basics. And that's why we give you the monthly breakout. That's when you see that once you get to those monthly energy costs and consumption, that I didn't realize I was doing heating and cooling at the same time. I never really thought about it. And when you move from HVAC to the plumbing side of the building, and you start talking about moving energy from one side to the other side, everything changes. This particular screen is trying to look at what happens at demand energy efficiency. And the point I want to make here, and why that says typical versus ask, and why at the bottom it says historical data, not min, max, or climate disruption. Because best is based on ASHRAE common, bin weather data, common, so that we can look at it and go, oh, in best, when we're looking at demand, the purpose of this screen is to show you that the ASHRAE cooling design temperature for Chicago is only 91.4 degrees. Most of you that have been to Chicago knows that it gets warmer than that, but we want you to know 91.4 is ASHRAE's number. And that's what this chart uses. We wanted 2 years ago to allow you to be able to go to 91.4, that temperature, and block it out and say, I want to know what happens when it's 100. What we're having to tell you is you need to ask. Every manufacturer's got load performance data for their equipment, so you can ask the question. We know that if you were an electrician, that you would know that if at the airport it's 91.4, that if you're going to run electrical wiring and conduit on a roof, that it has to be good for at least 120 and maybe 140, depending on local codes. If you're selling roofing, then you know if it's 90 degrees outside and you're doing a roof, it has to be rated for more than 91 degrees. In the air conditioning industry, we don't do that. The water side of the business, and we're water side people, those numbers are controlled. What the equipment works against is controlled. Unfortunately, for the air side of business, they do typical. And it's really, really hard. And what was really disappointing to us was that if we wanted to have you have the ability to go, I was on the roof today, and it's 100 degrees outside, and on the roof it's 120. What's the performance of this system with 120? And you know what I would have to do? I would have to put a note when you put that in that says data at that temperature is unavailable, because it's not published and it's not certified. We only use certified numbers and certified manufacturers. And if there isn't data for what happens when the outside air temperature or the roof temperature is 120, we can't do it. But this chart, its value is simple. At 91, what is the cooling system demand kW max? And what you're looking for is if this is my base system and I go to system 2, it went down. Oh, I go to system 3, it went up. If I go to system 4, it went up. The same thing is going on down here in your max heating demand. First scenario is the comparison among themselves. The next one is, well, you want me to electrify my building, and okay, heating's below cooling, heating's below cooling, heating's below cooling. What? Heating's above cooling, and cooling is above, and heating and cooling is above my building? Well, but it has the best EUI. Well, yeah, but it also means I'm going to have the highest bill. And it also means, it also exposes that if you're burning fossil fuels on site, then your EUI will always be higher. There isn't a penalty for electricity for source, but it does, if you're using gas, allow you to say, well, I'm at 26,000 therm. What if I change my boiler out and now this number for my existing system is 16? You ask yourself, is that decarb? Yeah, you're using less carbon. And that's what BEST is about. BEST is about the evolution of a conversation about consumption. BEST and HIAC is how do you use less electricity, less fossil fuel, and less refrigerant, and move it from here's standard case studies that you can hybridize to fit you, what your productive building has to be. In the future, we're going to expand. What in the heck can we do with this idea of using warming to decarb? How do we do more of that in building? And one of the things that I'm an advocate for is among buildings. It's about increasing cooling efficiency. It's about heat capture, not just from HVAC, but HVAC and plumbing or irrigation water. Do you know that the reason golf course greens and grass grows so great in Florida is because the rainwater is warm? If you're doing rain capture or thinking about it in a building and you want to change the temperature of that water by heating it up, by rejecting heat into that water, not only does it give you a way to get rid of your heat, it also gives you a way to do a better job of irrigation. But we don't tend to think about it. We separate it. Our advocacy is HVAC and water, about thermal opportunities and about phased transitions, phased so that the customer in the original goal, how do we do this simply? How do we get into a conversation about what is affecting versus leaving it to someone else versus being told? And where we want to help people the most is the people that don't have a choice. They're subject to what's in the street. It's what can you do? Well, I only have electricity. You can talk to me all day about using less gas. Guess what? There's no gas in the street. I'm not using any. So does that apply to me? It's BEST is applying to you. BEST is about your building, taking thousands of case studies with hundreds of ways to change it and making it as close to your building before you have to spend money. Did I emphasize BEST is free? One of the issues with those contractors, the original 50 giving us information was, well, are you going to sell this? Are you going to sell my information? Are you going to take my information and sell it? No, we're not. Really? And you're not going to expose my data? And you're not going to be mining the data of all the people that use BEST? No, we're not. Really? Pretty interesting. Owner focus, reduction in capital costs and operating costs. I'll go back to this idea of rhetoric, marketing HVAC, but case studies that the very reason you looked at the case study is the very reason it doesn't apply to you. Because you don't do that. You don't make that kind of building. You don't have that kind of requirement. You have your own productive building. BEST helps you identify and justify what you can control. Best is about your requirements for your productive building. And best is about your cost, your utility costs, your install costs, your operating costs. Best is about communication, consumption, and cost, multiple costs. So best takes you, puts you in the case study. It's a template, and I'll say this, it's in blue. If the design team you're working with, and remember, any of you can operate best. My granddaughter can operate best. Your facilities manager, utilities, your city planners, your own facilities people can operate best and get a template of what are the questions? What is it that we need to know? Our initial goal was and still is early modeling before you're caught, before you buy. So many times, especially in bigger buildings, the only modeling that's done is to verify that all the stuff that they've already put into your building meets a code, that it actually works. It's after the fact. When you start doing lead building, what was one of the biggest complaints? Oh, you have to do it twice. I have to do it that way, then I have to show you how much it's going to improve. They'd go crazy if they had to do 5 of them. I just did 5 for you at the beginning of this presentation. So it's what you can do. Whether it's environmental responsibility or a directive, I can tell you this, facilities people have a tough job because they have to be resilient and they get judged by what the cost is. The contractors today, the way they do their buildings, they want those customers for life. They want to take care of that customer. They want to give them what they want. They have to be able to make it a productive building, and they have to be able to make sure that everybody understands what's going on. You're not going to come home from the contractor's office and hear on your radio that the new version of iPhone 15 just became iPhone 16 and it's out of date. HVAC doesn't work that way. Water heating doesn't work that way. Your building doesn't work that way. You make those decisions and they last for years. They last for decades. People complain about, oh man, those old boilers, they finally gave up. How old were those boilers? 50 years old, 60 years old. You know, I am unfortunately old enough that I've seen my own systems I've installed replaced. So it's about you. It's about a productive building. It's about capital cost and the return. It's about whether it's new or whether it's a remodel. And it's about things that are changing. Trends are changing. The world is changing. And now because of it's, you think about, oh, I'm going to do dedicated outside air, or up in Canada, even residentially, I'm going to have to bring in ventilation air. So I want to recover the exhaust. I want to recover heat from the exhaust air. Become almost commonplace. It's not 100% solution, but it's part of a solution. Hydronic heat recovery is now really simple. Smart pumps, simple pipe, the life of the pipe, the ability that it doesn't corrode, that I can connect from one side of the building to the other side of the building by snaking around some pipes and putting a smart pump on it and recovering heat and reusing it, repurposing it without buying new energy. That's what this is all about. This is what BEST is going to evolve to do in more and more ways to help you deal with that. Transition. Yes, annual demand is important. Annual is important, but demand day action plans are key. When you leave this presentation, I want you to think about something that you can talk to an owner about. BTUs and water are really, really, really simple. It's 500, which is a factor based on the weight of water and of the temperature change and gallons. A 5-gallon bucket of water changed 10 degrees is 25,000 BTUs. They go, what? That's why I'm trying to move heat around in water or with water from here to there, because it's big. 25,000 is, in their mind, if they know, that's 2 tons. Now, it's not per hour, but water is per minute and heating and cooling is per hour. So let's have this discussion. How can it really work? Are you going to do rain capture? Are you looking at the ground? Are you looking at your own property? Are you looking at plumbing and HVAC? So you can show an asset manager, show the owner and the team how you're gonna address and what the impact will be of a system that lasts a really long time. When you get to a situation where you go, I've got this building and it just has to use a lot of energy. Ask for help. Who? Ask the city planners. Ask your public utility commission. Ask your utility. Ask me. Ask HIC. Ask IATMO. What do you think could be done? Can real energy credits be done? Are there buildings that make sense? Can I take heat in and out of the sewer? Can 200 homes that can't recover heat from the sewer actually heat and cool a school? Things are changing, and it's going to be fun because now, as I hear more and more, things that we didn't think matter, things that we didn't think made sense do make sense. It makes sense to heat and cool with water that's not super cold and super hot. Yeah, the old way was the bigger it is, the more different it is, the less we have to use. Smaller pipes, less horsepower. Versus, wait a minute, what about thermal losses? Let's get away from that stuff. And the discussion has to start with changing the way you think about it. It's real energy, sharing, and diversity. You want to know more? It's pretty simple. Go to hic.org or Google IATMO Best software. It'll come up. When you get there, we'll have multiple articles, multiple videos, tutorials, best practices section, and it'll get you started. You can send information to hic.org or you can send to me directly. Probably better to send it to hic.org because then it'll get assigned to somebody that may be able to address your question more directly. But where else can this happen? Thank you.
All right. Thank you,
Now,
Rick.
can you take the screen back, or are there any questions? Or
Yes, sir. We got a couple questions here in the chat. Thank you again, Rick. That was really awesome. Appreciate the deep dive on best software. I try to do it justice, and I try to tell all my friends to try to check it out and play with it. And like you mentioned, anybody can use it. So it is a free available tool. I think most of these questions may have been answered throughout the presentation, but we'll go along with it here. Matt said, thank you for the presentation. Great effort putting this tool together. Have we received any feedback from the contractors that have used or provided the original data?
one of the interesting comments that I got, I guess it was before Labor Day, but what he told me was, I'm actually using Best to explain to my own IT department how our software isn't addressing other systems very well. So I'm using Best to explain to our programmers that do our own software what they should be looking at or what they should be thinking about. Then probably, well, I'm thinking maybe it was 6 weeks ago, I got asked the question about, can you use Best to do what's called a thermal energy network? And if you don't know what a thermal energy network is, then just Google thermal energy network. But basically what it is central geothermal water temperature, that temperature of water delivered outside multiple buildings. And I said, yeah. I said, you're going to have to use an Excel spreadsheet or something, but you can go in and say, well, this neighborhood that we're looking at doing this, you can pick the building type from Best. put the system in that they might currently have in a building in an area you're trying to improve, and put in a more efficient system. And then you can go, I have 200 homes, I have 3 fast food franchises, I have 1 school, I have 3 public buildings, and I have something else, and expand it out that way. Someday, maybe we'll be able to do that for you as a preamble, but those are the kind of things that I do now.
All right, great. Someone had asked, where can we find this and how much does it cost for using it for our company? So I put a link in the chat for everybody. This is a free tool available for download. If anybody wants to check it out, there's a form right there you could fill out. And next question we have from Phil. What template would be closest for the largest single family home project, like an 8,000 square foot to 15,000 square foot home?
What
What template would be the
what you
closest
would
for a
do
large
is we have to sort of trick the program because it's commercial. We don't have a residential part of BEST yet, but you can basically set it up to be residential. You can put the physical size box model for the home. You make it 8,000, work out to be 8,000 square feet based on the footprint for the building. You pick the building weather data. You adjust the load data so that it matches with what you're either currently using or what you intend to use, and hit go. It's that simple.
All right. Well, hopefully everybody get a chance.
There are a lot more residential software programs, but when you get to a home that's that big, it may be actually a light commercial building.
So kind of the same way as you
modular
would
chillers,
commercial
etc.
buildings. All right, well, that makes a lot of sense. Appreciate that response, Rick, and thank you for everybody who put some questions here in the chat today. Rick, this is a great presentation. Thank you again for doing the deep dive today. If anybody's interested in joining the RPA or the Hydronics Industry Alliance and checking out what we're doing, there is a QR code here on the screen. You can click that and join the group and get involved with what we're doing. We'll have a few more webinars coming up. Thank you guys for joining. Check them out at Radiant Pros on YouTube. Thanks, guys.